Hello class and welcome back to section 8.1, part 2 of the video. So we should be on the back side of the notes now. We're going to go ahead and take a second to review factoring because we all love factoring. So if we look at the first two examples, 7 and 8, they are what we call trinomials, okay? It's a polynomial with 3 parts. And what a trinomial does is it factors into 2 binomials. So remember, the square root of x squared is x. So in the front of your parentheses, you're going to have x. Then you need to think, well, what will multiply to 12, or your C term, and add to your B term? So we're going to go ahead and do that. So if I look at example 7, I'm going to have my x in front of my parentheses. What's going to multiply to 12 but add to negative 4? Well, if you're not sure, go ahead and think of all your factors of 12. 1 times 12, 2 times 6, 3 times 4, and those are all my factors of 12. So what out of those would possibly add to negative 4? No, it's not going to happen with 1 and 12. 2 and 6? Very well could. So if I have 2 and 6, I need to be negative 6, so negative 4, so I would have negative 6 and positive 2. Then 2 minus 6 is negative 4. 2 times negative 6 is negative 12. So there is my trinomial factored. Going ahead to looking at example 8, I would have to say what multiplies to 2 but adds to 3. Well, the nice thing about 2 is it's a prime, so it only factors are 2 and 1. And to add to 3, they would both have to be positive. So it would be x plus 2, x plus 1. Now we get to number 9, and I notice this is not a trinomial. There's only 2 parts. It's a binomial. So what I want to do is look for a greatest common factor. 4 and 12 are both divisible by 4. And I would think, what's the largest I could take out of here? X squared. So I would have 4x times what gives you 4x to the third? Just times x, plus 12 divided by 4 is 3. And I already have an x squared. If you're not sure if you did it right, okay, think if I were to redistribute that, would I get back to what I originally had? 4x squared times x is 4x to the third, so that part is good. And 4x squared times 3, well, that's going to be 12x squared, so that works out. There is my factored form. So we're going to be looking at rational expressions, and now this time they're going to need to be factored. So if I go ahead and look at example 10, I want to look at my numerator, and I'm going to factor that. Good hint that I know when I'm going to factor is if I have, a binomial or a trinomial, and so I want to see first if I can factor. The problems we did on the front side of the sheet were only monomials, so we did not need to do any factoring. But if there's more like addition or subtraction, you want to see if you can factor. So looking at my numerator of that first piece, okay, I want to factor this. So what multiplies to negative 8 but adds to 2? Well, positive 4 minus 2, that will multiply to negative 8 but add to 2. And if I look at my denominator, need to say, well, what multiplies to 3 but adds to 4? Positive 3 and positive 1. Times, I look at my numerator in the second fraction or rational part, and I would factor out my greatest common factor. I can factor out a 3. So I would have x plus 1. And in the denominator, there's nothing that can be factored. Okay, then I'm going to go ahead and see if anything would cancel. Well, x plus 1 over x plus 1 will simplify to 1. So that's gone. Then I would look x minus 2 and x minus 2. Those are the same and they would simplify. So I look, is there any more x plus 3s? Nope. Or x plus 4, so I am done. So my final answer would be 3 times x plus 4 all over my denominator, x plus 3. One thing I do want to point out, this 3 here and this 3 will not cancel because there is addition in the bottom. The only way that something like that would happen is if you had a 3 like this. Those could cancel. In this case, there is not. So this would be my answer. You could also distribute the 3, and your other answer could have been 3x plus 12 all over x plus 3. That would be another equally acceptable solution. Example 11, once again, careful, this one's division, so when it's division, I remember I need to multiply by the reciprocal. So I'm going to go ahead and rewrite and factor as I do. This first rational expression does not have any factoring in it, so I have x plus 2 over x plus 3 times, now remember I'm going to do the reciprocal, so I'm going to put the bottom on top, x squared minus 9, that is a difference of perfect squares because the square root of 9 is 3. So I would have x plus 3, and remember it's always the opposite, I have x minus 3. All over, now I need to factor, so remember this piece is for there. And now I'm going to factor the part that I just put in green. So I have to say, well, what multiplies to negative 12 but adds to 1? So positive 4 and negative 3 would work. Now I go ahead and do any canceling that I can. Okay, x plus 3 over x plus 3 will simplify to 1. X minus 3 and x minus 3 will simplify to 1 as well. And I'm left with x plus 2 over x plus 4. There is my solution for number 11. Number 12. Once again, multiplying, so I can just keep it as is. I'm going to just factor all the pieces. So I'd have y minus 1, no factoring there. If I look at the denominator, I can factor out a 5. So y plus 3 times, factor my numerator, what multiplies to 6 but adds to 5? Well, 3 times 2 is 6, but it also adds to 5. And the denominator, sorry, this was a y. I wrote x, should have wrote y. So I'd have my what multiplies to negative 5 but adds to 4. Positive 5 and negative 1 multiplies to negative 5 but adds to 4. Now I look what can cancel or simplify. Y minus 1s, y plus 3, and it looks like that will be it. So I have y plus 2 over 5, y plus 5. And once again, you could distribute that 5, so it'd be y plus 2 over 5y plus 25. Example 13, go ahead and look at that. Right away I see division, so I know I will need to multiply by the reciprocal. Let's just start looking at this first rational expression and factor. So I would have to say what multiplies to negative 35 but adds to 2. 7 times negative 5 is negative 35, but that also adds to 2. My denominator, x squared minus 4. Difference of perfect squares. So don't forget the square root of 4 is 2, and then you always do a positive and a negative. And now we are dividing. So now since we're dividing, we're going to multiply by the reciprocal, so we need to flip it around. So I will have x plus 2 over x minus 5. And I simplify. X minus 5, x plus 2, so I'm left with x plus 7 over x minus 2. That actually doesn't look very nice, so let's try again. X plus 7 over x minus 2. There is my final answer. Okay, number 14, or before we do that, we need to look at what is a complex fraction. So that is when a fraction is inside of a fraction. Okay, so notice how we have a fraction being divided by another fraction. So in order to solve this problem, it's the same thing. It's really a fraction divided by a fraction. What did we do before? We multiplied by the reciprocal. So we're going to do the same thing in this case. So in order to solve this problem, it would really be x over 3 times x squared plus 1 over x. And same as before, I would notice my x's will cancel. That does not factor because it is not a difference, it's an addition. So I would just have x squared plus 1 all over 3. Okay. So let's look at some simplifying complex fractions. So I have a rational expression in the numerator, I have a rational expression in the denominator, and there is a division bar. This is going to tell me that I need to multiply by the reciprocal of the divisor. So what is below? So I'm going to rewrite what's on the very top. And as I do so, I'm going to factor. So I would have x squared times, now if I look at the denominator of this piece here, I have x squared minus 25y squared. So the square root of x squared is x, and the square root of 25y squared would be 5y. And since it was a perfect square, there's always a positive and a negative. Now we're going to go ahead and multiply by the reciprocal of this piece. So I do not have anything to factor out, so it'd be x minus 5 all over x. Now I need to simplify. Okay, x minus 5y and x minus 5y will cancel. X squared over x. So remember, this is really x to the first. Bring the smaller to the larger. So it's going to be 2 minus 1, which gives me 1. So I really have x over x plus 5y. And that will be my final answer for number 14. Number 15. Okay. Once again, I look at this. I'm going to do the same thing. I look at the fraction on the top, and I'm going to rewrite it. Except for this one is x plus 3 squared. So I'm going to rewrite it as x plus 3 times x plus 3. That's what that means. My denominator is x squared minus 16. So 16 is a perfect square. Square root of 16 is 4. And remember, if it's difference, it's always positive and negative. Now we just need to multiply by the reciprocal of this piece. So to flip that around, I would have x plus 4 all over x plus 3. Now I see what simplifies to 1. So x plus 4 over x plus 4 is 1, so that's gone. And then x plus 3 over x plus 3. And then I have x plus 3 over x minus 4. So then that is my final answer. And we have one more problem on this notes. I would like you just to take a second, maybe pause the video and think if you have any questions. If you do, write them down before we go ahead and move on to example 16. Okay, on example 16, just a little geometry reminder that you guys miss. You love geometry almost as much as you love factoring. So 16 says a parallelogram with an area of 6x squared minus 7x minus 5 square inches has a base, okay, of 3x minus 5 inches. Determine the height of the parallelogram. Well, I have to remember my equation for a parallelogram. For the area of parallelogram is base times height. In this case, I want to solve for the height, so I would have to divide by my base. So my height is equal to my area over my base. So I'm going to set this up. Height is equal to my area, which is 6x squared minus 7x minus 5, all over my base, 3x minus 5. So what I need to do is factor. This numerator, this value is not 1. All of them that we've been doing so far has been 1. So maybe some of you remember, or you like to do grouping. So you would say 6 times negative 5 gives me negative 30. You think of your factors of negative 30 that will multiply, that multiply to negative 30 but add to negative 7. I think negative 10 times 3 is negative 30, and if I add them, I get negative 7. Then remember, just going to kind of draw a little arrow off to the side here. We would rewrite this as 6x squared minus 10x plus 3x minus 5. And then we group this first part and the second part. My first part, I can factor out 2x. So I would have 3x minus 5 plus, I cannot factor anything out of this one, so I just write 1 out in front. And the other thing I would see is that there's 2 3x minus 5s. So I would have 3x minus 5 and 2x plus 1. So I would go ahead and continue my problem here. And I would say, well, the height is equal to 3x minus 5, 2x plus 1, all over 3x minus 5. And I would notice that the 3x minus 5s will cancel, so your height of your parallelogram is 2x plus 1. There's other ways that you can factor this. You can use the denominator to help you out. Notice how there was a very similar piece. The other way is just like guess and check method. Just to refresh your memory on that. If you wanted to do that, you would say, well, what multiplies to 6? 3 and 2. So I would just try this. And then the next thing that I would try is, well, what multiplies to 5? Well, 5 is really nice because it's 1 and 5. Those are my only factors. So I would do 1 and 5. Then I would go ahead and you check your 2 inners. When you multiply, you get 2x, and your 2 outers, that would get 15x. Can I use that in any way, shape, or form to get to negative 7? No, I can't. So what I would need to do is maybe switch them around. I have 1 and 5, so maybe I need to do 5 and 1. So now I would flip around. I would try 5 and 1. Try the same thing. This would give me 10x. This would give me 3x. Is there any way with those two numbers that I could get to negative 7? Yes, negative 10. So that would mean this is negative and this is positive. That's another way that you could factor it. Okay. So our final answer is that our height is 2x plus 1 inches. Okay, so we're going to stop the video here for today. If you have questions, write them down. Be sure to ask me in class. Otherwise, you go ahead and have a wonderful day. See you later.